Welcome to class number 7, where we're going to study Mars and the space rocks. And no, that is not a band, Mars and the space rocks. It is the planet Mars, right after Earth, and then after Mars is the asteroid belt, or this belt of rocks, and we're also going to study asteroids and things like that. So Mars is the red planet. Why do they call it red, you may ask? Well, I'll tell you. It's because they have lots of iron in the dirt, and iron rusts, and rust is a reddish-brown color, so when you look at the surface of Mars, it's all rusty, and so it has a reddish look to it. People dream about living on Mars. It's close enough to Earth where you won't burn up, or I'm sorry, it's far enough from the sun where you won't burn up, and it's not too far that you won't freeze to death, although it would be very cold there. But they dream about it. They imagine being able to create an ecosystem on the planet's surface that has its own, that we bring our own oxygen and we bring our own plants, and it creates this habitat where everything recycles, and that supposedly they imagine people being able to live there for a long period of time. But that's all a dream. They're working towards it, and they imagine being able to do it. So maybe as we start to do this class, we'll think a little bit about what it would actually be like to live on Mars. Mars is the last of the terrestrial planets. Remember, terrestrial planets are ones that are rocky and solid, and gas giants are the ones that maybe have a rocky solid core but are surrounded by a big ball of atmosphere or gas or vapors. So it's the last of the terrestrial planets. Mercury through Mars are terrestrial, and then all the planets out past that are gas giants. Terrestrial, so the surface of Mars is rocky, it's got mountains, it's got valleys, it's really barren, really rocky. There are two noteworthy volcanoes on the surface of it, two huge volcanoes. They're called Olympus and Mons. Now, neither one of them is active, but it does leave you wondering what would come out if they did erupt. Let's talk for a second about the gravity of Mars. So remember, the more mass equals the more gravity. So the bigger the planet, the more gravity. Mars is smaller than the Earth, but it's bigger than the Moon. So if the mass of Mars's mass would be less than Earth, Mars's mass would be greater than the Moon. So if I weighed 100 pounds on Earth, right here, and I went to the Moon, remember, I would have weighed 16 pounds, way less. We'd be super strong, lifting people up all the time. And then if I went to the Moon, or if I went to Mars, that 16 pounds would be 38 pounds. So 100 pounds on the Earth would be like 38 pounds on Mars. So that probably means that Caleb Powell could pick me up and lift me up over his head still, even if we were on Mars. But it'd be hard, much harder. Let's talk about the atmosphere. So the atmosphere around Mars, it does exist. It's just very thin, so there's not a lot of gases, and they're not very thick. And they're filled with dust particles, so it gives the sky a brown color. So when we look up at our sky, we see blue from the reflected light. And if you lived on Mars, you would look up and you would see a butterscotch brown, kind of a cream color because of all the particles in there reflecting dust. Not as attractive as the blue, in my personal opinion, but maybe you're a fan of brown. Also, the atmosphere being thin, it doesn't have the same protection that Earth's atmosphere does, so it's much easier for meteors to hit the planet without burning up in an atmosphere. As a matter of fact, it looks like at one time, because of all the evidence of craters on Mars, that there was a period when it was just blasted with space rocks. On the southern hemisphere, half of a sphere, or half ball, the southern hemisphere, there's a lot of craters, like it just got blasted and pelted with rocks. But the northern hemisphere is rather flat and not quite as blasted. So it actually looks like, again, no one was there to see it, but it looks like it might have been blasted so hard for a period that chunks of the planet were blasted into out of the atmosphere of Mars and landed on Earth, because scientists have found what appears to be chunks of Mars on planet Earth. So who knows, maybe at one point a while back, a big old rock meteor storm chiseled off chunks of it and sent them flying out into the universe, or into the solar system. Let's dig deeper into Mars. So Mars, in that gravity, has two moons, plural, moons. There's Phobos and Deimos, and so those two moons are, well, ugly. They're nasty looking potato shaped moons. They're not like nice round moons like our moon. They're kind of chunky and maybe look like a funky potato or something like that. Okay, so it's probably that these moons were actually space rocks that got caught in the gravity of Mars and are held in the orbit. As they're studied over time, they're actually being pulled into the planet Mars, so their orbit is getting smaller and smaller and smaller, and they guess that maybe in about 1 million years or so, those moons will crash into the planet. They're too small to make a solar eclipse, so on our planet, the moon is big enough that it could block out the sun, maybe a partial one on Mars, but not big enough to make a full solar eclipse. So 2 ugly potato-shaped moons, remember that for Mars. Next, let's talk about how it revolves and how it rotates. So remember, revolve is the planet going around the sun, and as we get further and further from the sun, it gets longer and longer to revolve around the sun. So 1 year, or 1 revolution around the sun for Mars is 687 days. What that means is that if you were 8 years old on Mars, you could drive. So it's almost double the number of days that the Earth takes to go around the sun. So revolving around the sun, 687 days. The rotation, or the turning on its axis, the rotation of Mars is 25 hours. Pretty close to Earth. Now you can imagine, unlike Venus, which is whipping around, why people would imagine being able to live on Mars. That's pretty close to 24 hours. You could actually have something close to Earth's days. All right, and then the other thing that's important to know about Mars is that it has a tilted axis like Earth, so it's kind of bent. And remember how the sun doesn't come in quite so direct at the top, making a winter, and then if you lean into it, it makes a summer. So there's actually 4 seasons on Mars. That's the good news. The bad news is they're all cold. They're freezing. So it gets down to -81 in the winter, and in the summer it gets up to a balmy, freezing 32 degrees. So the planet is always cold. But it is the closest temperature to Earth in our entire solar system. It gets cold enough in the winter to freeze carbon dioxide. So you know how water gets cold enough and it freezes? Well, carbon dioxide, if it gets to a cold enough temperature, it freezes and becomes dry ice. Well, presumably because it's not wet. So frozen CO2 is dry ice. It gets cold enough on Mars to actually freeze the carbon dioxide in the atmosphere. Now here's something that's very interesting and unique about Mars, is that Mars has water. But scientists believe that all the water on Mars is frozen in 2 ways. One is it's frozen up on the polar ice caps, just like on our planet at the poles. There's the northern and southern pole, the Arctic and Antarctic, and there's just huge masses and sheets of ice up there. And it gets warm enough that the carbon dioxide, or the dry ice, melts, but it never gets warm enough that the water melts. So they see tons of water frozen at the caps and the poles. Now there's also something called permafrost, which is water that's in the ground that never thaws. So it's permanently frosted or permanently frozen water in the ground. Like in our winter, you'll notice that the ground gets very hard because all the water freezes and turns to ice. So if you try to bang a tent peg into the ground, you'll notice you can't do that in the middle of winter. Well, it's always like that on Mars. So they have not yet found any liquid water, only frozen water or ice. But there were they've sent multiple, rovers across the planet. They sent out spacecraft and dropped these rovers off. Spirit and Opportunity were the 2 rovers that went across the surface of Mars looking for liquid water to see if it ever was there or if it is there currently. So what's the big deal with finding liquid water on Mars? Well, a lot of scientists want to keep the hope alive that they'll find life on Mars. They haven't found any to date, but they want to have that hope that maybe they'll find life on that planet. And if there is going to be life, then there would need to be liquid water, because liquid water is necessary for life as we know it. So there is some evidence that liquid water was once on the planet. There's this mineral here, a little picture of it, called jarosite. And jarosite is a mineral that forms in liquid water. So it's some evidence to suggest that maybe there was liquid water at one point. But still, just because you have water doesn't necessarily mean that you have life. It's a big jump to go from water to life itself. I find it interesting that the planet Mars was named after the god of war, where there's lots of death, and that's the planet where they're looking for life. But if you wanted to find it in the sky, this Mars planet named after the god of war, it's easy to find. It's a big, bright, orange-red planet. Obviously, it's not going to be twinkling quite like a star. And its blood color is actually what gives it its name for, or why they named it for the god of war. The blood red, rusty iron blood, has iron. There you go. So you can probably find it in the sky. Maybe we'll have a chance to get out there with a telescope or to get down to the planetarium and see if they can show it to us and be able to actually look at Mars in the sky for ourselves. All right, moving on from Mars to space rocks. You notice we're going to start doubling up on subjects in the class from now on. That is because the Earth, the Sun, the stars, the Moon have a lot more information and things to learn about them. While now as we're exploring the farther parts of our solar system, there's less for you to learn. So you're going to notice there's less notes. We're going to move a little bit quicker, but I do want you to see it and be exposed to it and retain as much as you can, just for your own interest and knowledge. So moving on to space rocks. First thing we're going to take a look at are comets. Comets are, you see them move through the sky. It's a moving object through the heavens, through the second heavens. And at the nucleus, or at the center of the comet, what we have is rock, ice, real ice, like made of water, and dry ice, which is frozen CO2. A comet is actually named for the Greek word kometes, which means head of hair. And you may ask, why would it be named after a head of hair? Ah, very good question. It's named after a head of hair because of all the stuff around it and that trails behind it. So this is called the coma of the comet. And so here's what happens. When the comet comes in and it orbits and comes near the sun, the heat of the sun starts to melt the rock, or sometimes not to melt the rock, starts to melt the ice and the dry ice, and some of the rock starts to trail up behind. So the debris, as the comet starts to melt when it comes near the sun, makes it look fuzzy, like kind of like a smudge in the sky, and leaves a trail of water vapor, dust, rock, and that is called the coma or the coma of the comet. Now here's an interesting thing. You'd think, if I drew this right here, and here's the nucleus with the rock and the ice and the dry ice, and here's the hairy, smudgy trail going behind it, you would think that the comet is moving this way, but that's not necessarily true, because remember we talked about the solar wind and how the Earth's atmosphere and the magnetosphere protect against the solar wind. Well, the solar wind determines the direction of the tail, because really there's no wind in outer space to have that trail go behind it. It is pushed by the solar wind. So it means that the comet could be traveling in this direction, but the solar wind is pushing it off in that way. So interesting fact there about the comet and why it is called a comet. All right, let's talk about the orbit of a comet. So a comet can actually orbit way outside of our solar system. So if here's all the planets going around in relatively nice, neat circles, a comet can orbit right in, zip around the sun, and then way back out past our solar system. So sometimes it can take hundreds and hundreds of years for a comet to come back around again. So the way they categorize them is short period and long period comets. A short period comet is one that takes 200 years or less to come back by the Earth again. If it takes more than 200 years, I mean, let's say it took like 1,000 years for that comet to go around, that would be called a long period comet. So remember, when a comet comes through, it leaves behind this trail of steam and vapors and dust and rocks, and there's something called a meteor shower that happens when the comet comes in, passes around our sun, and takes off again, and it leaves this trail, and then Earth passes through the trail. What we would see in the sky is just like a lot of quick lights zipping as little rocks and particles are burning up in our atmosphere from this cloud as the Earth passes through. So if you listen on the news or someone says there's a meteor shower coming, it means that we're going to be passing through the trail of a comet, and it would make lots of lights and shooting stars in the sky. Couple famous comets. There's one that's called Halley's Comet. That's probably the most famous one. It was first seen in about 240 BC. That's 240 years before Jesus Christ. That these Chinese astronomers observed it. But then later on, a man named Edmund Halley, he discovered that it had a 76-year orbit, so that it could come back every 76 years, which is a long time, which means that if you're lucky, it may be around once in your lifetime. The next most famous one is called the Hale-Bopp Comet, and that one is just famous because it's the biggest and the brightest comet that we know of. And then last, the third most famous comet is the Shoemaker-Levy Comet, and that one was famous because it actually broke apart and crashed into Jupiter. So there's an idea of comets and their orbits and a few famous comets for you. I want to talk about another type of space rock and see if we can tell the difference between meteoroids, meteors, and meteorites. So a meteoroid is space rocks or debris that come from planets or comets that's floating around in outer space. So if you were out in a spaceship, you could be dodging meteoroids. Now, meteors are meteoroids, so meteoroids that burn up in the planet's atmosphere. So this this last summer, we were all standing out in the street, a bunch of guys from church and myself and my wife, and Rachel looked up in the sky and she saw this big burst of flame, almost like an airplane had burst in the air in the middle of the day. And she said, "Did everyone see that?" And we all didn't see it. And she's like, "Oh, I saw it, I swear." And so the next day we looked in the news, and sure enough, it was a meteor that had burned up in the atmosphere in the middle of the day with a big bright orange light. So meteoroids floating in space, meteors burning up in the atmosphere. Meteorites are ones that actually didn't burn up in the atmosphere and hit the Earth. So most of them land in the ocean, but a meteorite could land on Earth or land on the land and create a big crater and a big explosion. So meteoroids floating in space, meteors burning up in the atmosphere, meteorites hitting the Earth. The last of the space rocks I want to touch on today are asteroids. Asteroids are huge meteoroids, and we talked about meteoroids being rocks and dust and space debris, but meteoroids are huge versions of them. They could be anywhere from the size of a football field to the size of the state, like picture Texas floating through, a big round Texas floating through the sky. Not something you would want the Earth to collide with. So these huge asteroids form what's called the asteroid belt. And no, that's not like a buckle to keep the asteroid's shirt in and tucked. It's this belt over here that is between Mars and Jupiter. So that's where most of these asteroids are found floating. So if here's Mercury, Venus, Earth, Mars, there's like this belt, and it goes all the way around the sun, of asteroids. These big, huge floating objects. And maybe they're not quite as tightly populated like that. I don't want it to look like a ring around Saturn or something. But in this area is just a lot of very large debris that orbits around the sun. So these large asteroids actually have their own orbit, just like a planet. Not as big as a planet, not even close, but big enough to do a lot of damage if they did hit a planet. They're not really sure where this asteroid belt came from or how it fits in our solar system. It's interesting that these are the terrestrial planets and these are the gas giants. So they're kind of dividing the terrestrial planets, the more earthy, rocky, Mercury, Venus, Earth, and Mars planets, from the gas giants, you know, your Neptunes and your Saturns, Uranus, and Jupiters and things like that. So just to know that's out there, but they didn't know where it came from. So there's just kind of maybe like a theory that maybe they were from remains of an exploded planet, that at one point they think maybe there was another planet in between Mars and Jupiter and it exploded and the debris continues to orbit around the sun. But nobody really knows. We just want to know what the asteroids are, and we really want to hope that they never hit our planet, which is not very likely. But I wanted you to be aware of that. I will see you in class.